Where are others? Only 6 students have logged in. Abdul Razak, ask your friends to join the class. Nikala, where is
Yes,
Prakesh? Ask your friends. Patish, Paul, Raghavendra, others. Okay, Chetan. Okay, I'll start. We have stopped at the relations. The three relations are E is equal to 2G into 1 plus mu. The relation between Young's modulus, rigidity modulus, and Poisson's ratio is E is equal to 2G into 1 plus mu. The relationship between Young's modulus, bulk modulus, and Poisson's ratio is equal to E is equal to 3K into 1 plus 2 mu. The relationship between Young's modulus, rigidity modulus, and bulk modulus, E is equal to 9 kg by 3K plus G. See, this bulk modulus, as I told you, bulk modulus K is given by sigma by volumetric strain. This bulk modulus plays an important role in case of fluid. Young's modulus, it indicates the stiffness of the material. Young's modulus, it indicates how stiff the material is. Stiffness, that is resistance to deformation. If Young's modulus of aluminum is 70 GPa, Young's modulus of mild steel is 210 GPa, it means that our steel is thrice stiffer than aluminum, thrice stiffer than aluminum. That is, if the deformation in aluminum is 3 mm, the deformation in aluminum is steel will be 1 mm. So resistance to deformation is stiffness. Young's modulus of aluminum is 70 GPa and Young's modulus of steel is 210 GPa, in the sense our steel is 3 times stiffer than aluminum. Similarly, bulk modulus, it talks about the stiffness of the fluid. When we talk about the fluid, bulk modulus talk about the stiffness of the fluid. For example, it is nothing but viscosity of the fluid. For generally a fluid should possess some viscosity. Yes, what do you want, Patish Paul? A fluid should possess viscosity so that it can we can lift a load. So fluid should have that capacity. The stiffness possessed by the fluid is nothing but the bulk modulus. It is given by bulk modulus. Okay. Next, we'll solve two or three problems regarding this engineering constants. Okay. The problem statement is like this. A bar of 20 mm diameter, same problem which I'm given the assignment. A bar of 20 mm diameter, 20 mm diameter, is subjected to a pull of 50 kilonewton. Is subjected to a pull of 50 kilonewton. The measured extension is 0.12 mm on gauge length. Gauge length in the sense along the length direction, delta L is equal to 0.12 mm. Gauge length, there is a length is equal to 250 mm. If you take the mild steel specimen, we will not take the for test will not take the entire length of the specimen. For study, we will take some confined region, that is called as gauge length. Okay, and the change in diameter delta D is found to be 0.00375 mm. Determine number one, lateral strain. linear strain, linear strain, linear stress, Young's modulus, 2 Poisson's ratio, 3 bulk modulus, 4 rigidity modulus, 5 volumetric strain, and change in volume. These are the unknowns given in the problem. So we'll go straight forward. Linear strain, which is equal to change in length by original length, which is equal to change in length is 0.12 divided by original length 250. Can you tell me the linear strain?
(4.8 into 10 power minus 4).
Yes. 4.8 into 10 power minus 4. Lateral strain to change in diameter by original diameter, which is equal to 0.00375 by original dia 20 mm, which is equal to
1.8 into 10 power minus 4.
Yes. Tell me the lateral strain.
1.8 into 10 power minus 4.
Okay. 1.875 into 10 power minus 4. Okay. Next, he has asked linear stress sigma, which is equal to P by A. Its load is 50 kilonewton, 15 into 10 power 3 by pi into area of cross section, circular cross section, 20 square into 4 is equal to yes. How much? How much?
159.23.
159.23 Newton per square.
Square.
Okay, Young's modulus C, you have to find. I can write sigma is equal to Young's modulus times epsilon. Sigma we know 159.23. That Young's modulus you better convert into 10 per MPa to Newton per meter square. Why? Because I want Young's modulus in terms of MPa. If it express, it is a little confusion because the Young's modulus will be generally in GPa. So better convert this into a Newton per meter square into 10 power 6 divided by this linear strain is 4.8 into power minus 4, which is equal to You can also keep in Newton per mm square, but generally it's better to express in GPa. It is of larger magnitude. How much? 331.6 GPa, right?
Yes, sir.
Yes, sir.
331.66 GPa. Okay. Next, we have to find Poisson's ratio. Nu epsilon lateral by epsilon linear, which is equal to 4.8 in 10 power minus 4, 1.875 to 10 power minus 4 by 4.8 into 10 power minus 4, which is equal to how much? How much? How much?
3.9 into 10 power minus 1.
How much? Poisson's ratio ranges from 0 to 0.5.
0.39.
0.39.
0.39.
Yes, sir.
Bulk modulus K. We know the relation E is equal to 3K into 1 minus 2 nu. E is found out to be 331.6 GPa, 331.6 into 10 power 9, which is equal to 3 into K into 1 minus 2 into 0.39, or K is equal to 331.6 into 10 power 9 by 3 into 1 minus 2 into 0.39. Tell me what is K?
Five 5.024 into 10 power 11.
5.024 into 10 power 11. Okay. Shall I write 502.4 into 10 power 9 Newton per meter square? Right? Right? Is it right?
Yes, sir.
Okay. Next, modulus of rigidity. G, instead I will call it as G, but the other authors you call they use the symbol C. Okay, E is equal to 2G into 1 plus mu, 331.6 into 10 power 9 by 2 into 1 plus 0.39 is equal to G, which is equal to how much? How much?
1 minute, sir.
Wait,
1.19 into 10 power 11.
1.19 into 10 power 11 or 119
119.3
0.3 into 10 power 9 Newton per meter
9.
square or 119.3 GPa or 502.4 GPa. Okay. Next, volumetric strain. Volumetric strain and change in volume. Since it is a circular cross section, let me write epsilon v, which is and delta v. Epsilon v, which is equal to sigma x by e into 1 minus 2 nu, which can also be given by epsilon x or epsilon into 1 minus 2 nu. Therefore, epsilon v, which is equal to epsilon x, in a linear strain only, it's 4.8 into 10 power minus 4, 4.8 into 10 power minus 4 into 1 minus 2 into 0.39. Therefore, epsilon v is equal to
1.1 into 10 power minus 4.
1.05 into 10 power minus 4 change in volume epsilon v is equal to delta v by v. Epsilon v we know, that is 1 point, I'll write epsilon v into volume since a circular cross section, pi d square by 4 into length is equal to change in volume delta v, 1.05 into 10 power minus 4 into pi into diameter, this 20 mm, 20 square by 4 into length is 250 mm is equal to delta v. Therefore, delta v is equal to
8.242
okay. Unit. What is the unit?
mm
Mm?
mm cube.
Yes, mm cube. Okay. This problem is completed. Next. Next problem will go. Okay. A bar of rectangular cross section 20 mm into 50 mm. Okay. 20 mm into 50 mm subject to load. Okay, here's that. Okay, let me call 20 mm. A bar of rectangular cross section of width, it should give in the examination of width 20 mm, or it should give the cross section of width 20 mm, depth 50 mm, depth 50 mm, length 400 mm, 400 mm, long is subjected to an axial tensile load of magnitude P is equal to 80 kilonewton. If the modulus of elasticity and modulus of rigidity are found to be modulus of elasticity, which is equal to 10 power 5 Newton per mm square, which is nothing but 100 GPa. Modulus of rigidity, G is equal to 0.4 into 10 power 5 Newton per mm square, which is nothing but 40 GPa. Determine, find, number 1, bulk modulus K, 2, Poisson section mu, 3, change in length, change in width, change in thickness, and change in volume of the bar. This is the given problem. Okay, bulk modulus. So it should be which relation you will use to find a bulk modulus? Which relation? You tell me. There are three relationship. If you go here, three relation. Which one you choose better for this problem? E is equal to 2g into 1 plus mu. He has given the rigidity modulus. He has given the Young's modulus. He has not given the change in width or depth. I don't know the lateral strain. I cannot find the Poisson ratio. Bulk modulus, there is no picture of bulk modulus at all. The rigidity modulus doesn't come to picture. Therefore, the suitable relationship is this. 9 kg by 3 k. Sorry, E is equal to 9 kg by 3 k. He has given the bulk modulus. What he has asked to find? Sorry, bulk modulus he has given. I can use either of the relation, but I don't know the lateral strain. But I don't know the, he has asked the bulk rigidity modulus. I don't know the Poisson's ratio. I cannot find the Poisson's ratio. Hence, the suitable relationship is this. Okay. Or if I know the rigidity modulus, I can also find the Poisson's ratio. Let us try like that. We'll use two relationship and we'll try to find if we know the E we know, G we know. Let us try like that only. Okay. E is equal to 2g into 1 plus mu. E is going to be 10 power 5, which is equal to 2 into 0.4 into 10 power 5, which is equal to 1 plus mu, or you tell me 1 by 2 into 0.4, which is equal to 1 plus mu, or mu is equal to how much? How much? Wait, you are taking so long. 1 by 0.8
minus 0.25.
minus 0.25
Sir, minus 0.25.
minus 0.25
0.25.
0.25 ಬರ್ಬೇಕು ನೋಡ್ರಿ
0.25, sir.
0.25 0.25. Next, we'll use a second relationship. E is equal to 3k into 1 minus 2 nu. E we know 10 power 5, which is equal to 3k into 1 minus 0.5, 10 power 5, which is equal to 3 into 0.5 into k, 10 power 5 by 1.5 is equal to k in Newton per mm square. What is k? How much? Why 10 power 5 by 5? Why 1.5? How much? How long you take? Tell me.
Ten power 5 by 1.5, sir.
Yes. What are you doing?
66,666.66.
You tell me in terms of 10 power 3?
6.6 into 10 raised to minus 4.
7 into 10 power 3.
Hope really correct again. Yes. Yes. Tell me.
66.67 into 10 power 3.
Yes. K is equal to 66.67 into 10 power 3 Newton per mm square. This is the first unknown we have found. Poisson's ratio also we have found. Nu and K. Delta L we should find. Okay. Delta L. Okay. Let me find. Nu is equal to, or I will find lateral. Okay. Linear sigma is equal to Young's modulus times epsilon. Sigma I can find sigma is equal to P by A, which is equal to 80 into 10 power 3 by area of cross section. Area of cross section, I should take B into D. This cross section should not take L into B or something. This is the cross section. Always you should take the cross section which is perpendicular to the load. Okay, that is why it's called a normal load. This is the cross section you should take. Load is acting like this. Okay, B into D, it is 50 into 20. Can tell me what is sigma? Sigma is found out to be 80 MPa, 80 Newton per mm square. Sigma by 10 power 5, that is E, is equal to sigma by 10 power 5, that is Young's modulus C, is equal to epsilon linear. Epsilon linear is found out to be how much? Shall I write 8 into 10 power minus 4? 8 into 10 power minus 4. Poisson's ratio, epsilon lateral by epsilon linear, 0.25, 0.25, right? 0.25 into 8 into 10 power minus 4 is equal to epsilon lateral. Tell me what is epsilon lateral?
Point 2 into 10 power minus 4.
Okay. Check it out. Point not
2 into 10 power minus 4.
2 into 10 power minus 4. 2 into 10 power minus 4 is equal to epsilon lateral. So the change in length dl, you will try in this way. Change in length dl can be calculated also using this formula, PL by AE. P is how much? 80 kilonewton. 80 kilonewton. 80 into 10 power 3. Length is 400 mm. Area of cross section pi into r. This is B into T. 20 into 50. 20 into 50 into 10 power 5. Or this is this way, or we know this epsilon we know. This is the easiest way. Epsilon linear we know, which is equal to delta L by L. Epsilon linear is nothing but 8 into 10 power minus 4 into length we know. Length is how much? 400 mm. This will give delta L. Tell me what is delta L? 8 4 is 32. 32 into 10 power minus 2, right? 32 into 10 power minus 2, how much you are getting? 32 into 10 power minus 2 mm, or delta L, which is equal to 0.32, 0.32, 0.32 mm, right? 32, if you take one second decimal point, 0.32 mm. Okay, I know delta L. Delta epsilon lateral, which is equal to delta B by B. Epsilon lateral is found to be 2 into 10 power minus 4. 2 into 10 power minus 4 into width is found to be 20 mm is equal to delta B. 2 2s are 4, 40, 40 or 4 into 10 power minus 3 is equal to delta B, or I can write delta B 4 into 10 power minus 3 mm. Okay. Also, length, width, thickness. Epsilon lateral, the ratio of lateral strain remains the same. Epsilon lateral is equal to delta D by D, 2 into 10 power minus 4 into 50 mm is the depth, is equal to delta D. 2 5s are 10, 100 or 10 power minus 2 mm is equal to delta D. 0.01 mm is equal to delta D. Okay. Next, volumetric strain, epsilon V, which is equal to delta V by V, or I can write directly delta V. I don't know. I can write directly sigma, either sigma by E or epsilon to 1 minus 2 nu, which is equal to epsilon linear is found out to be 8 into 10 power minus 4. 8 into 10 power minus 4 into 1 minus 0.5. Therefore, volumetric strain, which is equal to 8 into 1 minus 0.5, 4 into 10 power minus 4. Right? Next, change in volume, epsilon V is equal to delta V by V, 4 into 10 power minus 4 into 20 into 50 into length is how much? 400. Tell me what is delta V. Therefore, delta V, which is equal to
160
unit.
mm cube.
Yes, 160 mm. These problems are very simple. Okay. I've completed all types of problems. Most of the types of problems are completed. If possible, if time permits, I'll try to another 5 minutes remaining. Let me look into the problems. The rest of the problems are simple, very simple. After solving this problem, you can solve any types of problem. Okay. All other problems you should solve by yourself. These problems are just the substitution types of problems. Hope you can do this, right? Okay. Will you be able to solve these problems? Will you be able to do that?
Yes, sir.
Okay, I'll wind up here. All the best for your internals. Any doubt you can ask me anytime. I've also posted the assignment questions for your internals. Please go through those assignment questions. Only the questions will be coming from the assignment question. Please go through that and submit the assignment question by Sunday 5 p.m. Okay, without fail. So all the questions, don't merely just copy from each other. Just solve all the questions and submit it to me. Okay. Okay. Thank you.
Thank you, sir.
Thank you, sir.